Well, hi. Welcome to the US Lab. This laboratory module is actually made up of 24 modular racks. Now, some of these racks in this module are systems racks. That means the heating and the air conditioning and the power. But many of them house science facilities. Now, I'm going to use that word facility several times, and it's because what a facility is it's a rack or a series of racks that actually can do a lot of different experiments in the same discipline. For example, up here on the ceiling, now this may look like the ceiling to you, but on orbit, the ceiling, the floor, the walls, we're going to have experiments in every one of those places, and they're all the same to us when you're floating around up in space. Now, up in the ceiling, we're going to have the Space Station Furnace facility, and that's where we're going to grow semiconductor crystals. Many of these kinds of crystals are made up of large, heavy atoms in combination with very small atoms. So on Earth, we tend to have sedimentation, where the large atoms will be at the bottom, small atoms will be at the top. Up in space, in the microgravity environment, we'll be able to have homogeneous mixtures of large atoms and small atoms, and hopefully semiconductors, materials for computer chips, and other electronic uses that are very, very perfect. And at least we can understand how they work. This is the Express rack, and Express really stands for simple and fast. We'd like to be able to do science experiments up on orbit, see that we need to change the conditions, and then take those experiments out, bring them back to Earth, fix them or change them, and bring them back up. And this Express rack design allows us to do this. You can actually think of these experiments as being drawers in your kitchen, where we're going to pull out this drawer, bring it back to Earth, and replace it with another drawer. All the drawers are designed to fit the same interfaces. Even some of these experiments have actually already flown on the shuttle, and so we're going to be able to take the things that we've learned from doing shuttle science, take those experiments up, put them on the station, and be doing science right away. This is our microgravity glove box, and it's the place that we're going to use to work with materials that we don't want floating around in the cabin with us. And so, I don't know, think of a glass of orange juice. Down here on Earth, if I spill my orange juice, it's going to be in a puddle on the ground. But in a microgravity environment, it's going to be a giant ball of orange juice floating around in the cabin with me. Likewise, when we work with different chemicals, we probably want to keep them contained in a glove box like this rather than have them floating around in the cabin. And these glove boxes work great for that. In fact, they work great just if you want to have an experiment that you can do it all in one place and keep the pieces all together. This is the biotechnology facility, and again, a facility is a place where we're able to do many different kinds of experiments within the same discipline. The bioreactor, for example, here is a mechanism that is going to allow us to grow human and other kinds of tissues in space just like they grow in the human body. You're going to hear more about that later. But let me also show you that the biotechnology facility is going to allow us to grow crystals on orbit, protein crystals. Now, protein crystals are used to design drugs for diseases. And one reason we like to grow them on orbit is that we can grow them much more perfectly than we can on Earth. The space station is going to provide us a great platform to do life sciences research, looking at the effects of microgravity on the human body. Now, here is the Human Research Facility, and we're going to use this to actually check crew health, look at how we're doing, how our bodies are changing during long-duration flight on the space station. Now, we go to space for a microgravity environment, but we also want to find out the effects of gravity, and to do that, we have a centrifuge facility. And that's going to be back here in its own separate module, and that centrifuge is going to provide us with a force of gravity from 0 to 2 Gs, twice the force of gravity, so we can look at what that threshold is. Where does gravity really start to play a part in biological processes?